Okay, so we had a first session with Engineer Ohaga, who presented wonderful insights, especially regarding some wonderful insights there. Like this was his presentation, accelerating GE transition within 243 days.
Hello, he's not logged in. In fact, I'm giving.
Okay, Engineer Wasila is here. So previously we had Engineer Ohaga presenting that, and we have recorded the video we'll share with you, plus this slides will also be shared after the webinar session. We also had Engineer Wanjala, who presented telecommunication registration, silent areas, on that slide, and he presented gave us wonderful insights. He also left his personal contacts so that you can get in touch with him in case you have more questions. And of course, in case you need a mentor in telecommunication projects for registration. So please keep that in mind. And now we are going to have Engineer Andrew Wasila, who will present, and then we will move to questions. I hope engineers can bear with us because we were supposed to be doing them short and having, but I know members have questions. So Engineer Wasila, welcome. I will allow you to introduce yourself, and then during the session, my co-host will be taking us through in case of questions and other things. Engineer?
Yes, thanks Engineer Ndolo and the organizers of the session. I'm Engineer Andrew Masila. Been in telecoms industry for the past 15 years, working both locally in Kenya and abroad. And for this session, basically, I'll take you through what I presented on a personal level. So perhaps I'd request, perhaps this may not be shared outside. However, it's for your eyes during the session. And feel free to engage. And before I start sharing, I think being in telecoms, there's a difference and a great similarity between what you'd call technology and engineering. So you realize that technology can be used by everyone, including a secretary, including a bus driver, as well as an engineer. Now, the difference comes in not being able to use the technology. Of course, everyone can, and technology is becoming easier and easier every day to use. It's the approach to use technology. So the same way an engineer uses technology might not necessarily be the same way a layman would use technology. And I'll illustrate by means of my own experience, what I went through to do in order to achieve the registration. And yes, I appreciate what Engineer Wanjala shared. Yes, there's room for the engineers. The framework is being done, and there's great space. So when we think about artificial intelligence, as I'm building up my context, artificial intelligence actually is a combination of several disciplines. And of course, when you speak to the heart of it, who's the data scientist, who may not be an engineer necessarily, actually is more of a mathematician. When you look at the heart of it, what the data scientist actually lacks is the context. And that's where the engineer comes in. Because you can run all your good models, but if you have the wrong context, then it means you put in some information into a model, and basically your output does not speak to a solution, which is what the engineer produces. So actually the drift is in how you use the technology, not being able to use the technology. So with that, that sets precedence for me to actually begin the presentation. I'd request to have the host right so that I share my screen.
Engineer, just a minute. If you say the document is for our eyes only, and this video might be uploaded on YouTube,
Yes.
so I would rather you share the documents in terms of a document to members, to participants, like a message. You can just post it there for members to, like a file, attach it on a file, and maybe we will just have your table of content, if you can, so that members can just be looking at the content instead of going through the document on the page.
Okay.
You get the idea? Yeah. So you see that the chat button. There's a file sharing session. You can just attach the file there, and so that you will only have maybe the main area that you feel is public for people who can see. You can share on as a screen.
Okay.
Yeah.
All right, so I'll be sharing shortly. So basically, I'll go through how to do the report very briefly, and especially in this area of telecommunications. And I'll start with the training and experience report. So basically, I'll cover the report writing aspects and also delve into the specific area for telecommunications. So as part of the training and experience report, you have that the first section, of course, is the university. And this would typically be a Bachelor of Science Engineering degree, the approved courses. And there's a standard duration. And again, something else to note is in terms of the duration must follow each other and there must not be any gaps. So for instance, in my case, it was 64 months during the course, which was a Bachelor of Science in Electrical and Electronics Engineering, and then joined Safaricom from there. So the other key thing to note, just speaking on the basics of report writing, is that the training period has to be 24 months. So what does this mean? It means that if you joined an organization, perhaps you went straight into a role. However, as per the engineering code, you need to have been trained. So what you could actually do, the first 24 months need to have been training. So in as much as you're in a role, you didn't exactly get into the organization and start doing what you do. However, you got in and got trained for 24 months. So that is mandatory to have. And then from there on, there needs to be progress in how you've applied engineering in your work with consecutive dates and times. So for these dates and times, you're supposed to mention the period. For instance, August 2010 to April 2011, I was in this institution and this is the work I carried out. So for instance, I was the operation and maintenance engineer looking after the uptime of the network on a national scale. Then you mentioned on that column, and then the duration. So that period, for instance, is X number of months, is 11 months. So you state that. And also, it is expected that within your career, you'll be growing and you'll be promoted, and you'll move on from an engineer to a supervisor to maybe a leader in that function. So make that clear in your training and experience report so that it's clear that you've also been practicing and growing in your career. And if you've had any achievements, you can also state them briefly. So that is the first part of the training and experience report. And then the total of it all should actually be a sum of the period in months without any breaks. So for instance, if it is 200 months, then it needs to be a total summation of everything that you've experienced. Then after the table that shows your experience, you move to the details of the report writing. And in these details, basically, you expound on what is on the table, and you could highlight one or two areas which actually you performed exceptionally or worth noting and relating to the engineering experience. I understand that not all that you do in your work environment might be related to engineering or your business if you're running one. However, the aspects that strongly speak to engineering need to be highlighted in this case. And perhaps most of us interact with software on a day-to-day basis. So the key thing that to look out for is the design aspect. Before you get on, for instance, if you are a data engineer, data in the aspect of artificial intelligence, then before you get into a platform like Hadoop to extract some data, you need to demonstrate the engineering relevance of why you need to extract the data, how you are keeping the data. For instance, are you looking at a range of petabytes, terabytes, or exabytes? So those are the things actually to highlight in the report. And basically that's it with the training and experience report.
Hey.
Sorry, host, can you please mute the participant? The context. Okay, you can hear me now? Okay, so the project report needs to be relevant, capturing the concept and the context of the engagement. And maybe at this point, let me see if I can quickly share what my title is. Okay, so I'll just put it on chat. So this is within telecoms. That was my project, if you can see it. So it's a project report on a signaling optimization control system. So within the telecoms environment, we understand that there's quite a lot of signaling, and even right from university, there's quite a bit on signaling theory, why it is necessary, and also it touches a bit on control systems. So you can see that's where the engineering aspect comes into telecommunications, in as much as on a day-to-day basis, it's mainly software and systems you interact with. However, there's the engineering concept behind it. And basically, I won't go through the framework of the report. I'm sure you have it in a template somewhere. If not, it will be shared as a part of the additional documents that will be shared after this is done. So basically, you have your table of contents, your list of figures should be there if you've done any figures, and your list of tables. So one key thing to actually help to explain, especially if your project is based on software and systems, would be the use of equations and tables and models. Because when you look at software engineering, it's based on models. And I'll touch a bit on the emerging areas. When you think about something like containers, that is on Kubernetes, previously you used to have monolithic applications whereby you needed to write every line of code. So this reminds me of the Schrödinger equation, where you had to extract line by line and show how you got to the answer. So when you think about technologies like Kubernetes, it's basically condensed the code that you write on software. So actually, even nowadays, being a software engineer is being disrupted, because that particular aspect is actually being condensed into more automated forms. So when you think about it, now the role of an engineer becomes prominent, because the code that you needed a complicated software engineer to write now can be written by just about anyone. And actually, there are few online tools which, if you go, you can actually start coding and write your application right at this moment. So when you think about it, then when you bring engineering, then you have to demonstrate the additional value that you bring into the code. So the other aspect is, so I was just illustrating where tables come in. So for the tables, you'll basically create a model. Assuming you're writing a software for dynamic capacity management over power lines, for instance, then the knowledge of writing the software will be very critical to execute the task. However, the thinking of how load is actually distributed on a power line is actually the engineer's work, and the same engineer could go ahead and write the software, or could be given to someone else to write, however managed by the engineer. So I'll go to, of course, there's your abbreviation of terms if you've used acronyms. And then so apologies, let me take a quick break.
All right, engineer, we are having a wonderful session there, and so far, members, you are requested to send your emails as presented there privately, not to everyone. Instructions is important, and I have made sure that nobody can just log in and unmute their mic. So when you log in, if you want to talk, you have to now ask me to make you to unmute you rather. So I think engineer is back. Andrew. Engineer.
Mute now, all right. Can you hear me now?
Yes, engineer.
All right, so I'm back. So I was going through the report. So when you come to the report on the introduction piece, again, it's very important to be brief and concise in the report. So on the introduction piece, kindly do not copy and paste the Schrödinger equation and so many other things. What is being looked for is actually what you did into the project. So you can have a brief and very specific introduction, which should typically not be more than 2 or 3 paragraphs. And perhaps the word count for the introduction in terms of guidance should be around not more than 150, between 150 and 200 words. If you find that you have more than this, then find a way to actually reduce. And in my mentorship sessions, I actually help candidates to go about that. Then in the problem statement, remember that you have the context and the concept. Again, it's not a place to start putting equations and stories. It should basically mimic what you had in your topic. So in this case, I'll paste my problem statement. I think this is fair enough. I can paste it. So that was the problem statement. You can see it's very precise. So it's inadequate signaling capacity in the network driven by high signaling demand from smartphone devices while out of service units, leading to high costs of running the network. So already that tells you what the problem is, and it gives you an indication into the possible solutions that you can have. So if you find that you have a problem statement where you have to explain too many things, then perhaps you're already delving into the design as opposed to just stating the problem statement. Okay, then we'll move on. So in terms of the objectives, again, everything needs to be in sync. So the objective is managing high network signaling demand to maintain the cost in keeping up with high signaling demand, and to ensure an accurate forecast of signaling requirements. So those were the objectives. They need to be brief and need to speak to your topic and your introduction, and also what you're going to state in terms of the actual network design. So After that, then after stating your problem and objectives, then you need to come to a list of possible solutions. And I remember Engineer Wanjala talking about when you're thinking about transport solutions, it could be either microwave or IP. And when you're talking about high capacity, then you look at fiber and IP as being the most viable options. So again, those need to be stated under the list of possible solutions. And in this case, you need to state all the available engineering solutions. Remember, there could be other non-engineering solutions. However, the solutions in this case need to speak to an engineering aspect. So like in this case, one was surgical removal of smart devices out of the network. Actually, that solution was using a bit of artificial intelligence and machine learning. However, you understand that the problem being addressed is the signaling on the network. Then number two was controlled network access into the network. So after stating the problems, then you need to come to the preferable solution. And this is also very critical. I'll also paste this on the chat, so I hope you're following me. So this was an analysis of the possible solutions. Yeah, it's fine. I'm not projecting. It's my report I'm actually going through, so I'm not projecting. I've seen a comment. So you can see the aspects, and these are engineering choices that you are making, that one solution was chosen because it's comparatively cheaper.
Engineer, we can't see your information. You haven't sent it. I think you paste, but you haven't not sent. We can't see any.
It's on the.
On the
really?
Nothing is being shared on the chat.
On the chat. Okay. And now, can you see anything? Or
No.
do I need to be the host to share to everyone?
Not necessarily. You can share information. You can just, if you're typing, you can type to everybody. You don't need to be a host.
All right. So can you see I've been typing quite a few. Can you see?
Can you see my message now?
Yes, I can see it.
We cannot see your message. Can you send something?
Everyone. All right. There.
Yeah, there
can
we can see.
Now?
Yes.
All right, that's better. So comparatively, it is the cheapest option in terms of simplicity, in terms of customer experience. And you'll find that perhaps the option that you choose out of the available options might lead to maybe an additional cost or a trade-off in one thing or the other. So that needs to come out clearly, that you'll say, in as much as option 2 might not be the best in terms of an engineering consideration, it was chosen because it meets the needs of the task, and the additional burden has been mitigated by one or two factors, which is what exactly was stated there. And then from the preferred solution, now you come to the analysis of the current solution. And this is where now you actually paint a picture of the real problem and how it exists. So in this case, it was a demonstration of how the signaling load occurs on the network. And then from there, and actually I used a table and some calculations for that. So for this particular aspect, let me just quickly copy this onto a document. All right, so I can show you an example of how to abbreviate. Okay. Okay, I'll share a table shortly. Okay, so I'm just sharing a table, doc 1, all right? So
Our time for this session is also running out, engineer.
all right, so net path. Okay, for some reason I'm not able to send to everyone. However, I'll just continue running through the rest of the document.
Engineer, why can't you share to everyone? You are a host. I had put you a host some time back.
All right, we send. Okay, hold on. Let me share it again. Save.
Otherwise, I hope members are keeping safe as engineer is preparing that. I hear kids playing in the background. So please keep safe. Your brains are still needed outside there after COVID is defeated.
Okay.
Yes, engineer.
So it seems to be some writes on my machine preventing me from copying it out, but I can share later.
Yeah, I think you can. You just prepare what you want us to share. Then you will send it. You will send it to me. Then I will. When I will be sending the report, I'll send it to everybody so that they can also have a look at it.
Okay.
Maybe you can redact what you don't want to be there. Then we can share the document, your document. But members will be requested that it's only for their eyes only to guide them in their preparation for their PIP or rather professional interview.
Okay, so what I will share is how I came up with the existing design. It was a software solution, however, there were calculations involved, and they were summarized in a table and a summary column. Then from the design is the bill of quantities, which the bill of quantities, if it's, in this respect, for instance, if it's something fully software, it would be prudent also if you bought something like a hard disk, maybe you're storing data and you needed to put it, whether it's computing resources, and I'll touch a bit around cloud technology. For those dealing with cloud technology, you understand that there's how you size for compute and storage, and actually there's a way to put engineering factors. For instance, the operational threshold should be 70%. So those are some of the aspects which you can bring in while designing so that you factor in the engineering considerations when you're actually deploying. And then in terms of the cost benefit analysis, so for instance, in this case, it was saving costs in terms of signaling. And basically there was a payback period because the project costed, for the discussion's sake, 10 million Kenya shillings. And the 10 million Kenya shillings repaid itself over 1.5 years. So that's how you do your payback period to actually show that there was value from what you actually did. And then, of course, there's the implementation plan where you show the tasks that you did, how much it took, the activity, and if there are any dependencies. And very important on the report is to have your conclusion on the areas you covered, And also it would be prudent to also highlight what the future has and how your solution is still relevant into the future. Also include references, and very important in the report would be an evidence of you working. So if it was in the data center, you need a few photos showing you actually going through the project and executing it. So that was my journey in terms of registration. It took around 7 months, but it was worth it. I actually got registered last year. And as we speak, I'm currently mentoring to other engineers within Safaricom and a few outside Safaricom within the telecom space. And I'll actually paste my details on chat to everyone. You can reach out to me after this. So I'm basically done with my session. If there are any particular questions, I'm happy to take them at this point.
All right, thank you for that, engineer. But because we are using the basic version of this webinar, so I will have to end this session, and then we can start another session for questions and answer for yourself to tackle.
Okay.
And then after that, we'll have Engineer Wachira Kahoro.
Okay.
So I think members can just log in and log out and log in immediately.